11, 10, 9, ignition sequence starts. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
Rockets and space travel have been topics of great intrigue across the world for decades. Because of the success the United States achieved during the late 20th century, rockets quickly became an icon of human genius. They have pushed the limits of technology, ushering in a new age of exploration beyond Earth's horizons. The famed space race, America's passive battle with the Soviet Union to reach the moon and explore space during the Cold War, was a crucial stage of worldwide rocket development. For the first time in history, man had been launched out of Earth's atmosphere, and then 7 years later, out of Earth's orbit. What most people are not aware of, however, is that the leading cause of the United States' success during this time was a former esteemed member of Hitler's Nazi Party, Wernher von Braun. Although he had been deeply involved with the Nazi Party, Wernher von Braun and his creation of the Saturn V rocket marked a new age of exploration and space travel, encountering new methods of engineering and rocket development. His ideas and expertise on rocketry proved to be extremely valuable when he exchanged them with American scientists. As a result, America was able to make its first manned mission to the moon, paving the way for future space exploration missions. Even at a young age, von Braun displayed interest in rocket propulsion and space exploration. However, he failed to apply himself throughout his primary and secondary education, which led to his failure in both science and mathematics. His educational inadequacies drastically changed, however, when he discovered the book, The Rocket into Interplanetary Space, by the German author and scientist Hermann Oberth. Frustrated at not being able to understand the mathematical principles, von Braun studied hard at both math and physics until he was proficient in both subjects.
I sent for that book. My first reaction was absolute dismay because this book was full of mathematical equations which I didn't understand. Of course, I wanted to understand the book, so I went to my math teacher and asked him what I should do to understand these formulas. But it was the first case of a real incentive in my life.
Due to his ability to understand advanced physics and his passion for rocketry, von Braun quickly rose to prominence among other rocket engineers. He started testing forms of liquid rocket fuel and collaborating in rocket experimentation with other European scientists. His natural leadership abilities took him to the position of technical director at the Nazis' rocket production plant in Peenemünde, Germany, one of the most modern technological facilities of its time. During his work at the Peenemünde plant, von Braun began experimentation on the aggregate or A-series rockets. The most well-known of the A-series rockets was the A4, also known as the V2. This vengeance weapon was a ballistic missile which Hitler had used in the latter end of World War II as a last-ditch attempt to turn the tide of the war. However, Hitler's endeavors proved to be futile, and it soon became clear that the Axis powers would not win the war. After much discussion, von Braun and his top scientists decided to abandon the Nazi rocket laboratory and willingly surrendered to the American forces. They had good reason for this, as an encounter with the Soviets was likely to end poorly, and von Braun's team didn't wish to lose their decades' worth of work. When they arrived in the United States, they were initially detained and interrogated about their advances in rocketry and propulsion. However, von Braun's intelligent and charming manner soon landed him in a position in Fort Bliss, Texas, where he worked on ballistic missiles for the U.S. Army. Yet, von Braun's most important contribution to space exploration would not come until many years later, prompted by the space race, when he was authorized to build the Saturn series rockets. On October 4, 1957, the Soviet Union launched an artificial satellite named Sputnik, becoming the first country to send a man-made object into orbit. Over the years, Soviet engineers and scientists would gradually pull in the lead of the race to control outer space, otherwise known as the space race. The Soviets would go on to successfully conduct other firsts, including first human in space and first three-man space team. However, this would all change once Kennedy made his famous declaration on the future of space exploration in 1961.
And they may well ask, why climb the highest mountain? Why 35 years ago fly the Atlantic? Why does Rice play Texas? We choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
During this time, von Braun was sent to work on U.S. space missions and was eventually put in charge as director of the new George Marshall Space Flight Center in Huntsville, Alabama, where he exclusively worked on the manned spaceflight program. Building on his ideas from his previous creation, the V-2 rocket, von Braun explored new ways to make his rockets lighter and still resilient. In 1957, von Braun and his team started development on the Saturn line of rockets that were immense enough to carry people out into space and to the moon. The most notable of these was the Saturn V, which utilized technological advances from the new decade. Adversely to the V-2, which was solid steel, this new design used stronger, lighter structures of metal tubing and resulted in a much lighter construction and a bigger carrying capacity. While von Braun was a very skilled and gifted rocket engineer, it was his leadership and task management skills that allowed his team of scientists to succeed in creating the technology required to create rockets that were capable of landing humans on the moon.
Some of the skills that are not widely emphasized amongst engineers and scientists are the ability to communicate and to motivate people and to be a good leader. Those were critical to the success of the program. People who worked for von Braun were extremely loyal to him.
His charismatic personality and ability to make people believe in him was fundamental to both the planning and production of the Saturn series rockets. Even after the Saturn V rocket was completed, von Braun remained a major figurehead in the field of rocket science. Over his lifetime, he was able to generate massive interest in space while expanding the exchange of knowledge between American scientists. However, von Braun's public image was not without flaws. Despite his contributions to both American military work and space exploration, there was varying skepticism of his reliability among government officials. The V-2 rocket, von Braun's main contribution to Germany's military, was built mainly by slaves from Nazi labor camps. Although the rocket only killed 2,000 people directly, the construction of the rocket was responsible for approximately 20,000 to 30,000 Jewish deaths from beatings and malnutrition. Von Braun never expressed a truly violent side, but he was willing to turn a blind eye to the horrors of Nazi Germany if it meant he could continue his experiments.
To build weapons, to become part of the Nazi regime, these were unpleasant things, but he was young, he was passionate, and he did what he felt he needed to do.
For the United States government, the space race was an extremely important political opportunity, a way of proving that they were superior to the Soviet Union in terms of government and economy. Because of this, they whitewashed von Braun's history with the Nazi Party in exchange for his ideas and expertise with rocketry. Today, von Braun remains an icon of the American space movement. His work with the American space program continues to shape the way the United States perceives space exploration. Through his leadership and ideas exchanged with the American public, von Braun was able to raise massive interest in both the political and technological aspects of space travel. Even now, the Saturn V remains the largest and most powerful rocket brought to an operational level. The technology used to construct it continues to influence modern-day rockets, like the NASA Space Launch System, dramatically advancing rocket development and paving the way for future manned space exploration, reaching into the depths of space.